El doctor Benjamin ABELLA está en Estados Unidos, es el director clínico del Centro de Investigación del Resuscitation Science Department of Emergency Medicine, University of Pennsylvania. Él ahorita está en el hospital trabajando. Bueno, está en Chicago, lo mandaron del hospital de viaje a Chicago y por eso nos acompaña vía, ¿cómo se llama? Vía video. Y pues para mí es un placer presentar a este ponente. Recientemente estuvo en México y estuvimos platicando y lo que hacen en Pensilvania de investigación acerca de materia de reanimación es increíble. Él participó en la revisión y en la escritura de las guías para 2015 de la American Heart Association y pues su ponencia habla y presenta más de lo que yo podría hacer ahorita. Entonces quiero agradecerle al doctor Benjamin ABELLA que esté con nosotros.
Okay. Well, yes. Buenos dias, everyone. I'm very sorry I can't be there in person to give this lecture. I wish I could. I very much enjoy visiting Mexico and my colleagues and all of you there. And I also applaud the organizers of this conference. It's a very, very important time for resuscitation science. There have been a number of important breakthroughs in the last few years, 5 to 10 years really. And so this is a great time for the conference, and I applaud you all for coming, and I hope you are learning quite a bit and enjoying yourselves. So we'll see how this works through the wonders of modern technology. I'll be speaking to you from Chicago, Illinois. And my goal today is going to be to share with you some insights into the science behind CPR, and specifically the science behind CPR quality, the way we think about CPR and the way we deliver CPR. And one of the big themes of today will hopefully be to convince you that the way we do CPR matters quite a bit with regard to how we can save lives from cardiac arrest. So not all CPR is the same, and there is now a growing science just in the last 10 years in understanding how CPR relates to cardiac arrest outcomes. So first, I thought I would give a little bit of advertisement, so I apologize for this, but the American Heart Association, as you know, has been very involved in CPR and cardiac arrest science for many years. And about 8 years ago, started an entity called the Resuscitation Science Simposium. It's an annual conference devoted to cardiac arrest and CPR science, and I invite you to join us. I'm one of the co-chairs of the conference. It will be taking place in New Orleans this November, and it's a really wonderful chance to learn more about the science behind what we do. So I encourage you to think about it, and you can certainly contact me if you have questions, but I would very much love to see some of you there. Good. Well, to begin, as you know, cardiac arrest is when the heart rhythm changes from a normal electrical regular beat to something like this. This is ventricular fibrillation. And as you all know, cardiac arrest represents the abrupt, sudden loss of all cardiac output. So there is no blood flow whatsoever during cardiac arrest, and therefore someone collapses and CPR is absolutely required. So cardiac arrest is unique among medical diseases, and that is 100% fatal within minutes unless CPR is delivered. And unfortunately, we often require members of the lay public to deliver CPR. And as you all know, this is a big challenge because asking teachers, lawyers, restaurant workers to deliver CPR is a big request, and it may be difficult. Nonetheless, if CPR is not delivered within minutes, death is certain. Now, in the United States, just to give you a sense of how big a problem this is, around 400,000 people each year in the United States suffer cardiac arrest. Most occur in the out-of-hospital setting, and survival rates are quite poor. So in published studies, survival rates are less than 10% survival to hospital discharge. I show you here very round, what we call estimated ranges. The best single study this year, it looks like national United States survival is around 9%. So 9% of people are discharged alive from the hospital. So that's very, very low. And I'm sure in many other countries, including Mexico, survival may be similarly very low. Now, when do people actually die from cardiac arrest? Well, this is a schematic to show you when mortality occurs. Assuming a number of people who go into cardiac arrest, despite with CPR and defibrillation. However, we do get some people back. We call this ROSC, or return of spontaneous circulation. ROSC is getting your pulse back. Unfortunately, many of these people still go on to die, and they go on to die within days following initial resuscitation, so that very few people leave the hospital alive. And this is, in essence, the big problem we are. Now, we're going to focus today in my lecture just on this initial phase, the delivery of CPR and defibrillation, and specifically CPR. Now, the history may be interesting for some of you. CPR is not as old as you might think. The modern form of CPR that we deliver was only invented around 50 years ago. The development of chest compressions was at Johns Hopkins Hospital, shown here. And these three physicians, Drs. Knickerbocker, Kuvenhoven, and Jude, studied CPR in the laboratory and found that if you push rhythmically on the chest of pigs, cardiac arrest. Now, chest compressions were put together with this. This is mouth-to-mouth breathing, which was developed by Peter Safar, an anesthesiologist working both in Maryland and also at University of Pittsburgh. Mouth-to-mouth, developed by Peter Safar, was put together with compressions put together by the Hopkins team, and modern CPR was born. And I show you here an early conference on the delivery of CPR just some 50 years ago. So it spread all over the world very quickly, and as you know, now millions of people undergo CPR training. It's a very, very large enterprise. Billions of dollars are spent on CPR training infrastructure by organizations such as the American Heart Association and the American Red Cross. So this is a big deal, and it's saved many, many. CPR is based on the chain of survival, and of course many of you know the chain of survival, where you have to recognize the arrest, you have to deliver CPR, followed by defibrillation and then ACLS care. And this is the chain of survival that is taught in textbooks all around the world. Here's an example of an American Heart Association textbook that teaches CPR. So in the last, I've given you a background. Many of you know this material already, but just to get us all on the same page for what we're going to talk about next, which is the quality. So if we train CPR, and are we delivering CPR? Or asked a different way, does the way we deliver CPR make a difference? And to share with a number of clinical studies, hopefully convince you that the way matters a lot. This was a major, published now about 5 years ago, a multi-center trial looked at CPR. The idea here, 911, and tell the dispatcher they thought they had a current in the United States. Dispatchers will talk you through. And that's a wonderful thing, because you can change the script and look to see if it affects the outcome. So for example, in this study, subjects were randomized to either what was called standard CPR, which was a instructions to deliver compressions and breaths, 30 compressions, 2 breaths for each cycle, or what was considered a little crazy at the time, just whatsoever. Turns out survival was much better, almost 40% better proportionally in the group that showing that the way we do see a big difference in cardiac arrest outcomes. And by dropping breaths, at least for bystanders, we can improve delivery. Now, what's going on here? We generally believe that breathing is important during CPR phase, that not survival. Well, this real animal experiment that was done some time ago, this is an animal in cardiac arrest. And I'm showing you vertical blood pressure animal. Each vertical dotted line is a compression, and each pause are pauses and compressions. Compressions do not generate blood, and blood pressure plummets, and you have to repeat the whole cycle. So a lot of time may be spent in interrupting a loop. Compare that to this animal that got compressions with no pauses, and I'm showing you both superimposed so you can see the difference between the two tracings. It turns out if you do compressions with no pauses, you can deliver a steady state pressure and flow, and this may be much better, at least for the first few minutes of cardiac arrest. Explanation for why dropping breaths in that multi-center clinical trial might have made a difference. Now, there's another way to look at compression quality, and that's compression fraction. Compression fraction is very simple. It just means the percentage of time that compressions are delivered during a cardiac arrest resuscitation. So if someone has a resuscitation for 10 minutes and compressions are delivered for all 10 minutes, that's a 1.0 or 100% compression fraction. If compressions are delivered half the time, that's a 50% compression fraction. Well, this was a large out-of-hospital study done in a large pre-hospital consortium in the United States. And what they found was the higher the compression fraction, the better the survival. When compression fraction was very low, survival was lower. When it's higher, it went up. It seems to plateau around 80%. You see there the highest bar seems a little bit lower. It's not statistically distinguishable, so probably it's just reaching a plateau once you get to 80%. So again, the way we do CPR, the quality of CPR makes a difference. Now, what about depth? We all believe that compression depth is important as well. And you may remember 10 years ago, the guidelines suggested anything between 1.5 inches and 2 inches was acceptable compression depth. That would be between 38 millimeters and 50 millimeters of depth. So this is an animal experiment where they asked, is that true? Is that range acceptable? And I'm going to show you coronary perfusion pressure, or CPP, over 3 minutes of CPR. Now, it turns out CPP, or the pressure in the coronary arteries, is very important. And I draw a line here at 15 to show you that if you don't get CPP above 15, generally animals will not survive resuscitation. Well, this is the CPP over 3 minutes of CPR at 2 inches of depth. This is the CPP at 1.5 inches of depth. These animals were all in ventricular fibrillation. After 3 minutes, they were shocked, and this is the survival. So a dramatically different survival rate when compressions were given at 2 inches versus 1.5 inches. So again, the way we do CPR matters, and I would ask you, do you measure how deep you compress when you do CPR? If you don't, maybe you should. There are devices and ways to do this, but in general, we think the important thing is to push very, very hard. And you can see here, a little bit of shallower compressions may make a difference in survival. These are the human data to support this finding. These are just from 3 years ago approximately. And in this large out-of-hospital study, the same thing was found. The deeper you push, whoops, I apologize. The deeper you push, the better the survival, both with regard to one-day survival and survival to discharge. Now, we looked at this in the form of a meta-analysis. We wanted to pool data from a number of studies to try to determine, is there a sweet spot for compression rate? That is to say, too fast may be bad, too slow may be bad. Is there an optimal peak? And what we found when this was a lot of work, we pooled tens of thousands of cardiac arrest cases from a number of studies, we found that indeed there was. When compression rate was around 95, it was the best. It turns out when you compress too fast, it's also bad. So compression rates at 120 were damaging. Compression rates that were too slow were damaging. So either extreme was not optimal. Now, we did not find a sweet spot for depth, and to explain this figure as quickly and easily as we can, in all cases we looked at, deeper was better, and it really mattered. So you do want to compress deep. We don't know if there's too deep. No clinical study to date has suggested that there is a too deep of compressions. Now, I want to push this concept a little bit further. In some cases, CPR may actually be more important than defibrillation to improve survival. I know that may sound remarkable, but in fact, this is the case, and this was a study done on this. In Seattle, for several years, they tracked survival following standard American Heart Association guidelines. That's the orange bar there. And they recognized that many times they would go to an arrest and no one was doing CPR. The patient would be in fine ventricular fibrillation, they would shock, and the outcome was poor. So they wondered, perhaps better if no bystanders actually doing CPR, to do 90 seconds of CPR first and then defibrillate. And this is what they found. They found when they delivered CPR first, survival actually improved. And this was statistically significant. They delayed defibrillation to deliver good CPR. Now, this is not a randomized trial, and there are a number of possible flaws to this study. This is a randomized trial that shows the same thing. So this was done in Oslo, and this is a randomized trial of shocking first versus 3 minutes of CPR first. And I'm showing you time from collapse versus the chance of survival. And they found a remarkable thing. If medics get there very quickly, now I don't know what the roads are like in the city in Mexico you're in right now, but if one gets there within 1 or 2 minutes, can you get there in 1 or 2 minutes in Mexico? If you get there within 1 or 2 minutes, defibrillation is the better strategy. If, on the other hand, it takes 10 minutes, 12 minutes, and in many US cities it takes that long as well, if you get there that long, shocking first is the worst strategy, and CPR first is the better strategy. So a very interesting result, again suggesting the importance of early, prompt CPR. Now, if we believe that CPR quality matters, and if we believe that CPR is perhaps even more important than defibrillation, it becomes very important to measure how we do with CPR. And this is a defibrillator. This one happens to be made by Philips, but similar defibrillators are made by other companies. Full disclosure, I get no money for showing you this picture from Philips. Zoll and Medtronic make similar ones. This just happens to be the one we use at our hospital. It has sadness or equity on purpose because I want to stay unbiased sensor for Philips about 15 years ago. These defibrillation pads can measure ventilations. So this puck in the circle goes on the chest, and you compress through this puck, and it measures rate and depth of compressions. The pads measure ventilation. And I want to show you now an actual cardiac arrest from some time ago. On the top are ventilations, the middle is ECG, and the bottom compressions. And you can see compressions are being delivered. They stopped to analyze shock. The rhythm changes, and they now see this is ventricular tachycardia, and they begin compressions once again. So you can imagine that if you use a device like this, you can learn quite a lot from measuring CPR, and this is quantifiable. This is a quantitative measurement of CPR delivery, which is a very exciting thing if you're going to do training or debriefing or education around CPR. Now, we did a study some time ago using a version of this defibrillator that did not give any feedback, that did not show users their compression rate and depth. So it was only a recording device. And we asked a simple question. How is CPR being delivered? And we found that CPR is being done very variably. That is, poorly sometimes, well other times. And what you see here is a histogram showing you a distribution of compression rates. Now, the red dotted line is at 100 compressions per minute. If CPR is being done perfectly, you would only expect bars at 100. But what you see is bars all over the place, too high, too low, very widely variable, because this is in a hospital, actually 3 hospitals. So these are ACLS-trained providers. Now, we looked at survival and asked, does the compression rate matter by survival? And in fact, it does. Patients who get their pulse back had a much faster compression rate than patients that did not get their pulse back. So again, it may very much matter, and it's frightening to see how variable CPR delivery was. Now, this has been found during EMS care as well, and I'm going to show you now a study of ventilation during pre-hospital ambulance personnel care. This is a recording strip showing you ventilations, and you see the ventilation rate is around 30. That's quite high. That during CPR, we want a ventilation rate perhaps around 8 breaths per minute, 6 to 8 approximately. But they went way too fast. Actually, it's worse than that. They had a first group of medics who went at a rate of 37. They stopped the study and said, guys, we're doing a very bad job. We need to slow down. When they retrained the pre-hospital providers, the rate was still 2 times faster, maybe 3 times faster than it should be. So again, very variable care delivered during actual cardiac arrest. There are other things you can learn when you quantitatively record CPR. This is called a pre-shock pause. And you see here, compression is being delivered. That's over here. Then there's a pause, and then a shock is delivered. Well, this is a 15-second pre-shock pause. One could ask whether that's okay, whether that's too long of a pause or not. And one can study it using these defibrillators. And we did this study. This is Donna Edelson, one of my fellows, did this work with me. And we looked at the duration of the pre-shock pause versus the chance of the shock being successful. And what we found was the longer the pause, and you see here it was divided into 4 equal groups, ranging from about 10-second pauses to about 30-second pauses, or longer than 30 seconds, the chance of the shock being successful fell quite a lot. So delivering a shock right after compressions is very important. And this was something that was not known at the time. Automatic external defibrillators now have shortened their pre-shock pause time based on these data and others because they have a mandatory hands-off period for analysis. So it's very important to deliver the shock right away. Now, if you want a nice summary of the things I've been sharing with you, this is a position statement put out by the American Heart Association about 2 years ago. It's an excellent summary of CPR quality data and some ideas on how to improve CPR quality. You can find it online on the journal Circulation. I want to share with you, though, 2 things that are very interesting from this statement. And these are thought pieces. These don't exist. These are not real, but they're things to stimulate our community to think more about how to improve CPR. These are report cards. And could you imagine if we had report cards for cardiac arrest to show us what we were doing right and wrong? The idea is it could be very helpful, and there's going to be a need for more research to study things like this. So on the left is a general report card based on just viewing a code. So questions like, was the scene orderly and quiet? Was CPR started right away? Was an airway put down right away? Was the defibrillator applied quickly? These sorts of things. And you could imagine saying yes, no, or somewhere in between. On the right, you see a report card that is quantitative, that relies on data from a defibrillator. And you can imagine this could be very helpful, so you could learn how good was your CPR. I wish defibrillator manufacturers could develop defibrillators to print these out on a little sheet of paper after every cardiac arrest. They would be very helpful for training and education purposes. Anyway, these are in that 2013 Circulation document, and I encourage you to look at that article and think about these things in your communities and systems as well. Now, I'd like to spend a little time talking about actual cardiac arrests so we can talk about how real this is. This is Tim Russert, and he was a famous television correspondent in the United States. He had a cardiac arrest at work in 2008, and he had a myocardial infarction that led to his cardiac arrest. And you could imagine this would be the best sort of patient to have, a witnessed cardiac arrest, ventricular fibrillation from a coronary cause. Nonetheless, he did not survive. And I know for a fact the AED that was used on him had a 25-second required pre-shock pause time. Now, if you remember what I shared with you, pre-shock pause matters a lot, too much. So this is an example of how CPR quality may have actually influenced survival, or in this case, non-survival, in cardiac arrest. Now, this person had a different kind of cardiac arrest. This is Michael Jackson, and he suffered a cardiac arrest from a drug overdose at home in 2009. Now, would better CPR have saved him? I don't know, because he had a respiratory arrest, so perhaps not. But it turns out he got CPR in his bed, and his bed was very soft. You know, he was a wealthy man. He had a very nice, big, thick, soft mattress. You could imagine if you do compressions on a soft surface with no backboard, you may not get good depth. That is to say, you may not compress the chest very much. And he died from his cardiac arrest. Now, in his case, whether deeper compressions would have mattered is hard to say, but it probably matters for other people that depth be adequate by doing CPR on a hard surface. Now, I like to end on a happy story. This person had a cardiac arrest, Fabrice Mwamba, in 2012, and he had a remarkable arrest event. His arrest was on the soccer field, and he had a cardiac arrest for 78 minutes. These are the people doing CPR during his cardiac arrest. And this is him fully survived in his hospital room after recovery. So he had 78 minutes of CPR. But I'll tell you that there were very few pauses. He got shocked correctly multiple times. So this is proof of concept that you can have 78 minutes of CPR and make a full recovery. Not everyone will get this, of course, but it shows us the possibilities that exist with high-quality, aggressive CPR. Now, in 2010, the guidelines incorporated this in an important way. I shared with you earlier the importance of no gaps in CPR, and for bystanders, perhaps no breaths. They invented something called hands-only CPR, and this has been pushed worldwide by the American Heart Association, and it's been supported again in 2015. The basic idea here is instead of ABCs, airway, breathing, circulation, the new fundamental approach is CAB, circulation first, compressions first, and then we worry about airway and breathing. And this is both bystander CPR as well as CPR delivered by medics. So, some key take-home points here. Cardiac arrest is not hopeless. Hopefully I've convinced you that the way we do CPR can make a big difference, and hopefully by better CPR we can improve survival. If we're going to do a better job of CPR, we need to minimize ventilations, we need to maximize our chest compression rate and depth, and we need to consider things like these defibrillators that provide CPR feedback, and also things like report cards and debriefing tools so that we can improve CPR in our communities. As I mentioned early in this lecture, this is a very exciting time for resuscitation science. There are many things that are on the horizon, and we need all of our input. We need scientists around the world, clinical scientists, to study things like debriefing or report cards. And hopefully, many of you in Mexico can study what it would take to improve CPR in your EMS systems or your hospitals. With that, I want to acknowledge and thank my colleagues at the Center for Resuscitation Science, shown here. Day. One of the things we very much believe in is the importance of getting out there in the community and sharing the science and sharing the importance of teaching CPR to improve survival. And with that, I thank you very much for your attention.
Thank you very much, Ben. been a pleasure to have you here. Si alguien tiene alguna pregunta para Ben. ¿Preguntas? I'm just asking them. ¿Alguna pregunta que alguien le quiera hacer a Ben? ¿No hay preguntas? Preguntas.
Okay, very good.
He's saying that in the special hospitals, sometimes they also have the problem to have the bad quality CPR, and I'm going to complain that. Pero la pregunta, ¿cuál es? Perdón. Ok. Ok, gracias. Nos comenta el doctor de la mala calidad en la reanimación. Pregunta. He's asking the CAB.
Okay.
That he says that no, almost not everyone knows that situation.
Yes.
They guess they have an intubate airway. It's better. Oh, the question is if there's something different to do, if you are different with a different specialist like anesthesiology, internal medicine, if there's a different protocol. You want to answer that?
Yes. Yes, that's a very good question. So the compression-only approach, I should emphasize, is for bystanders. That is not for medical professionals. But if you're going to teach CPR for the public, compression-only may be the better strategy based on science. However, in the hospital setting, or even for ACLS providers, certainly intubation is important, and certainly breathing is important. It's only to emphasize that compressions may be the important first step. So in the hospital setting, absolutely, intubation is crucial. The CAB is to emphasize that you wouldn't want to take a lot of time to do the airway before you made sure you were doing compressions. And so it's more a philosophic point rather than a literal point. But absolutely, in the hospital setting, one should start compressions while you're setting up to intubate. Intubate as quickly as possible, and then continue compressions and breathing together without pauses. That's the best approach in the hospital. The compression-only approach is for dispatch-assisted CPR or for public CPR. Hopefully that answer makes sense.
Yeah, all right. Another question? Perdón, otra pregunta. I'm asking them in English, sorry. There's another question.
Bueno, la evolución de la reanimación en los últimos 15 años ha sido de 5 compresiones más una insuflación. Actualmente es de 30 más 2 insuflaciones. En base a las investigaciones que van a realizar o que se están realizando, la tendencia va a ser aumentar las compresiones y desaparecer paulatinamente las insuflaciones a nivel prehospitalario, o dado momento en un futuro veremos un RCP asincrónico en el medio prehospitalario.
I'm not sure I completely understand. You mean for the next guidelines in 2020, or?
He's telling us like if there there's gonna be a difference in the next years to make some continuous CPR or like the Tucson Arizona protocol, something like that? Is there a tendency?
Yes, yes, I think so. And in many states in the United States, the pre-hospital systems have moved towards the Arizona system of compressions first. So for example, I work in Pennsylvania. The ambulances there do 200 compressions before anything else, which is essentially the Arizona protocol. And that's based on some of the science I've shared with you today. The guidelines, the HA guidelines, have said that that's an acceptable strategy. So they already are saying that's okay. Whether or not they will move towards more continuous compressions in all settings, I don't know. It's hard to say. I can say that we do believe you need to breathe for patients at some point. So whether you do that with continuous compressions, with overlapping breaths, or interposed, we don't know. So there's still some science to be developed there, but certainly many systems in the US, pre-hospital systems, are moving towards compressions first, like Arizona. And systems in Mexico may want to think about that if they aren't already doing so.
Thank you, Ben. The last question, la última pregunta, perdón.
Bien, nada más, a ver, espero darme a entender. Mire, con respecto a lo que es la tabla de paro, yo quisiera saber qué tan efectivo es que nosotros iniciemos las compresiones en la cama, porque en lo que tarda en llegar el carro de paro, que es el que tiene la tabla, nosotros iniciamos las compresiones en la cama. ¿Qué tan efectivo es?
How quick?
Again, she said that how effectively is
Okay.
to begin the compressions in the bed, because the code red activation takes some time.
Yes, yes. That's a very, very good question, because compressions in a bed have some limitations because the surface is not firm and so forth. But I think it's very important to begin compressions right away. And even if it's not perfect, the science seems increasingly clear that some form of CPR is better than no CPR. So for example, I don't know the situation in Mexico, you would not want to wait for the code team to show up to do CPR. You want to start CPR right away. Even if you're not 100% sure it's a cardiac arrest. If a patient is unresponsive and is not breathing normally, the AHA teaches that you have to start compressions. If the code team takes 3 or 4 minutes to get there, that's a real problem. And that's very common. In the United States, it takes minutes for the code team to arrive. So the nurses typically start CPR right away, within seconds, hopefully. But that's a great question.
Buena pregunta. Thank you very much, Ben. It's been a pleasure to have you here.
Well,
we hope next
muchas gracias.
year we can have you in here.
Yes. I would very much like that. Muchas gracias to the audience. And once again,
Thank you, Ben. Have a good day. Keep in touch. Bye.
okay, thank you very much. Okay, bye-bye. Hasta luego.